Okay, so here we have to write a cosine function for the data that we're given here. Now, this is the general form for a cosine function, and the first formula I want to use is to get the b value, and the b is equal to 2 pi divided by the period. Now, the period is the length horizontally, the horizontal length until you complete a cycle. So if I were to graph this, then I would be graphing y values of 120, 135, blah, 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 goes up to 180, and then it comes back to 120. And the distance between 0 and 0.6, that's going to be your period. So you can say 0.6 minus 0, that's equal to 0.6. Now you can see that after that, it starts to repeat itself. It goes 120, it goes up to 180, and down to 135. So the next one would be 120, blah, blah, blah. But it takes 0.6 until it gets back to that original number and starts to repeat those same numbers again. So that means 0.6 is your period. So our b is going to be 2 pi divided by 0.6, which is the same thing as saying 20 over 6 pi, which is 10 over 3 pi. So that's our b. So we know we're going to get that in there, 10 over 3 pi. Now, is there a need for a c here? Well, a c, that is, well, actually, normally the formula has parentheses around like this. The c would be the phase shift. But we won't actually need a phase shift here. And the reason why is our smallest y value is 120. Our biggest y value is 180. So if we were to graph what's going on here, we are going to be starting at the bottom. We're going to hit a peak at 180. It's going to be starting at 120. And then it's going to dip down, and it's going to head back to 120 again. So if we were to sketch this, then we would have 0 down here, we'd have 120, we'd have 180. But actually I need to put the y-axis right here, because that point at 120, it's happening when x is 0. So 0, 120, and then we would also have, what is that, 0.3, 180? But ultimately, we're finding out that the thing is starting at the bottom. And whenever you have a cosine that starts at the bottom, then that means you just have a regular cosine with a negative in the front. So a negative in the front of a cosine starts it at the bottom. If you don't have the negative, it starts at the top. Okay, so normally a cosine starts at a 1, but if I put the negative in front, it would start at a negative 1. But there's going to be a little bit more to this. But ultimately, we are going to have to use a negative in the front for our a. But we are not going to need the plus c, that is a phase shift. That would be responsible for moving this thing to the left or to the right. So if you start with just putting slider there and you put a positive number, it actually moves it to the left. If you put a negative number, it moves it to the right. We're not doing any of that. We're going to be starting on the bottom point. We're going to be starting directly on the y-axis at the bottom point. So we don't need a plus c. So let's just get rid of that. We don't even need it. So it's really just going to be bx in this case. So it's going to be bx, close parentheses, plus d. Okay, but now we need to figure out what the a and the d are. So we know that this thing is going from 120 to 180. Now, and we can actually get a formula for our a. Our formula for the a is take the highest point, add the smallest point, and take an average. And we also have a formula for our d, And I just realized I made a mistake. It's actually 180 minus 120 over 2. Whereas this one is the one where you do 180 plus 120 over 2. So for D, you're taking the average. But for A, it looks very similar to the average, just with a minus. So make sure you put a minus when you're doing your formula for A. So in general, A is whatever the max Y is minus the min, all over 2. And for D, it's whatever the max plus the min is, over 2. So if we just do those calculations, we are going to get that this comes out to 60 over 2, and that'll be 30. And now there's one more modification. Turns out this is not actually going to be A. This is just a formula for the absolute value of your A. So the absolute value of your A is going to be 30, but sometimes your A will be negative. And in fact, we said that this one will need that negative because we are starting at the bottom. So if I had just put only a number in the front here, let's say I put something like 10. Well, it turns out that's just going to get the amplitude to go up to 10, down to negative 10. But if I put a negative 10, now it starts at the bottom. Okay, so ours is going to be a negative 30. And you might notice, okay, that's not really getting us what we want because it's going to bring us up to 30. But we're trying to go all the way up to 180. Well, let's calculate our D. Our D is going to be 150. So if I now add in the 150 at the end, then let's go check to see if it's doing what we want. It hits a max of 180, a min of 120. That's good. Okay, but we also said that there's supposed to be a 10 over 3 pi in front of the x. Let's put that in. 10 over 3 pi. Okay, and now obviously this graph is a little tough to look at, but let's change the window, and we're going to change it from 0 to, say, 1.2. So that way we can see what's going on a little bit better, just like the x values that are in our graph. And let's see, it starts at 0, hits 120. At 0.3, it hits 180. And then at 0.6, it hits back on 120. So this is our full equation. It would be y equals this. Now, technically, it's actually a t instead of an x, but that doesn't change the graph on Desmos. It knows what to do. And there you go. You got your equation. So the most important pieces here are your formulas. The first formula we used was 2 pi over the period. Then we have a formula for the absolute value of A. That's max minus min over 2. But keep in mind, sometimes you got to use a negative in case your cosine starts at the bottom. And then your formula for D, well, that's max plus min over 2. Hope you enjoyed this video. All right, take care. Bye-bye.